we're going to start integration by parts. Basically, it uses the product rule and breaks it into specific parts. Okay, so what we're going to do first is we're just going to use the rule, and then I'll show you how it came from the product rule in another video once we're used to using it. Okay, so basically the rule says that if you have the integral of u dv, it equals uv minus v du. It's really unfortunate that they use u and v, but I want to be consistent because that's what you're going to see in university, so I'm leaving it like that. So you're going to break, so the idea of this is you're going to break a question that you can't find the antiderivative of, that you can't use substitution for. You're going to break it up into two parts, the u, and the rest of it is going to be the dv. Okay, for selecting the u, you're going to use this little mnemonic, LIATE, and it stands for logs, inverse trig, algebra, which is going to be like a polynomial, like x squared, x cubed, okay, trig, and then exponents. So you're going to, the first thing that you come to, that's what you're going to pick as your u. So if there's a log in the question, it's your u. If there's no log, you just move on down the list. Okay, so let me just show you with a little example. So I have a way of organizing these questions, which I will do in the next video, but for this one, let's just use the rule and see what we see. Okay, so I look at the question and I start with logs. Do I have a log? Yes. So that log is going to be my u. Everything else in the question is going to be my dv. Okay, so this is not a substitution. This is just breaking things up into its part. Okay, so my u is going to be ln x, and then everything else in the question is my dv. So the dv is x squared dx. Okay, and your dv should always have a dx in it. Okay, now what you need in the question is you need a u, a v, and a du. Okay, and we have one of those things. We have a u. We don't have the v and we don't have the du. So we're going to have to get those. So I can just take the derivative of this. So I'll just say derivative, which is with respect to x, which is du dx, which is 1 over x. And then I can split this up and get 1 over x dx. So now I have a u and I have a du. Okay, and then I'm going to take the dv and I'm going to integrate. Okay, so let me just show you something up here. If I integrate 1 dx, what would I get? Well, you should get x, right? So if I take the integral of 1 dv, I should get v. So I'm going to integrate here and I'll get v, and then I'm going to, oh, maybe I'll just show that step. So I'm going to integrate dv and integrate x squared dx. So I'm just integrating both sides, and that will give me v, which is what I want. And then the integral of x squared dx is x cubed over 3. And you don't need to put the plus c because when we answer the question, we're going to put a plus c. So let's leave it out in the parts. Okay, so now I have my u, v, v, du. Okay, so I'm just going to write this down here, write the rule down here. So we have u dv equals u, v minus v, du. Okay, so now we're just going to fill those parts in. So there's the u, there's the u dv. So it equals u, v, minus v, du. Okay, do you see how I did that there? Let me get a different color. So I said u, v, okay, and then minus v, and then du, which is this. There we go. And then this is going to be the answer. So I'm just going to rearrange this. I'm going to put this out front so it doesn't look like part of the argument. And then this is going to become x squared over 3 dx, which luckily I can just antiderivative. And then this is going to be over 9 because 3 times 3. And then in my final answer, I will say plus c. So that is the answer to that question. And I did that by using this rule called integration by parts. Okay, so in the next example, I'll show you how to organize this a bit.